Calorimetry is a technique for indirectly measuring the change in heat of a system. This is done by measuring the temperature change of the surroundings of a system. The system consists of everything that participates in the chemical reaction, and the surroundings consist of everything that does not react, such as the spectator ions. For example, if I wanted to measure the change in heat of the reaction between sodium hydroxide and hydrochloric acid, I could mix the two and see if the surrounding solution increases or decreases in temperature. Calorimetry is useful for determining whether a reaction was exothermic, meaning it released heat, or endothermic, meaning it absorbed heat. In order to create a successful calorimeter, the system and the surroundings need to be as isolated from the environment as possible. This can easily be done with 2 styrofoam cups. 2 cups are used so that the system is extra isolated, since styrofoam cups are not perfect insulators. So, if we were to try and measure the heat of reaction between sodium hydroxide and hydrochloric acid, we would place a solution of hydrochloric acid, which means that it's dissolved in water, into the styrofoam cups. Then we would add the solid sodium hydroxide and measure the temperature of the solution for another few minutes. Tip: in order to make sure that the sodium hydroxide is fully dissolved, use a stir bar, but make sure the bar is on the side of the cup so that a water vortex isn't formed. And another tip: use a lid over the styrofoam cups to minimize the heat lost during the reaction. The change in temperature of the surroundings for the dissolution of sodium hydroxide and hydrochloric acid can then be used to find the change in heat of the surroundings. After we find the change in heat of the surroundings, we are able to find the change in heat of the reaction. This means that if the system's heat increases, the surroundings' heat decreases. Now we can find the change in enthalpy of the reaction. If the change in enthalpy is positive, meaning heat was added to the system, the reaction was endothermic. If the change in enthalpy is negative, meaning that heat was released from the system, the reaction was exothermic. Now we could see if bonds were broken in the reaction or if they were formed. And calorimetry made all of these discoveries possible.